Welcome to the project demonstration of hand main based fan speed controlling system. So here the main application of this project is we are going to regulate the DC fan speed based on the hand motion. Means whenever we keep this hand in normal position, then the speed of this fan will be set to the medium level. So if you want to increase the speed, just bend forward your hand, so then the speed will be increased. That will be noted from this LED indication. So when it is continuously on, that is indication of the fan speed will be increased. When it is on, when it is bending the hand forward direction, that's indication to the fan speed will be increased. So when it is be off, means the fan got reached to the maximum speed. Same for the backward also. When it is bending your backward, then the speed of the fan will be decreased. Parallelly, that will be indicated through the LED indication. When it is continuously on and bending backward direction, the fan will be decreased. When it is off, it reaches the least level of the speed, means the lower level of the fan speed will be reached. And for bending forward backward detection, we are making use of this ADXL 335 MEMS sensor, which was interfaced to the PIC16F72 microcontroller, which is the main brain of our project, which will taking input from this MEMS sensor. Based on this forward backward bending position, it will provide us the variable voltage in Y direction. So it actually ADXL 335 will provide us the 3-axis inputs, that's X, Y, Z, but our project required only one axis, that is Y axis. We are making use of that, and that was interfaced to the A1 pin of our microcontroller. Based on this tilting angle, the system will control the speed of this DC fan through the C2 pin, that's a PWM pin C2, that was interfaced to the transistor board, where we are using the BC547 transistor as a switch. So continuously using PWM signal. So when it is normal, 50% of duty cycle for the PWM. When we are bending forward direction, then the duty cycle will be increased. Means we are increasing the on time of PWM signal, so that when we increase the on time, the average output voltage from our transistor board will be reaches to the 12 volts maximum, because we are providing the 12 volts DC inputs. And again same for the backward, the duty cycle will be decreased and PWM off time will be increased, on time will be decreased, so that the fan speed will be decreased. So this is the technical part of our project. And coming to the power flow, we are providing 230 volts AC input to this transformer, which will step down the 230 volts AC to 12 volts of AC. And as we are using the electronic components utilization that require DC power supply, that to 5 volts for this part section, microcontroller sensor parts, and 12 volts for this part, the output load. So we need two outputs. So for that, this 12 volts of AC will be converted into pulsating DC with help of these 4 diodes, which will acting as a full wave rectifier. Capacitor will do the rectification parts. So filtration part here, rectifier will do the rectification AC to pulsating DC, and the filter will remove the pulses and provide us the 12 volts pure DC voltage. That 12 volts DC voltage is input to the transistor board for this load purpose. And we are using 7805 regulator. This is a 7805 regulator which will take 12 volts DC input to provide us the 5 volts DC output. That is operating voltage to our MEMS and our PIC microcontroller. So this coming to the motherboard, so it has a filtration just for to provide removing the pulses if is there any ripples generated while we execution. And this is the reset switch to restart the microcontroller. Just it will only restart the microcontroller, it won't erase the program. And this is the crystal oscillator which will provide 20 megahertz of oscillating frequency to the microcontroller. Based on this clock frequency, it will execute the instructions. So let us see the demonstration. So before on the power supply, you can just mount your this gloves on your hand for demonstration purpose, and keep the hand in normal position parallel to the ground. So it will be set the duty cycle of 50%. Right, now on the power supply, initially the light will be on and off 2 times. You can do that, see, reset that. Initially fan will be off, the light will be on and off 2 times, and after that, due to this inputs, it will be set to the 50% speed. So when I am bending forward, then the speed is increasing slowly. Once it reaches the maximum speed, then the speed will be locked at the maximum speed only. Same for the backward. Right, fan is off. Again 50%, again increased. So in this manner, based on the hand motion only, we are going to control the speed of the fan. Bye. Thank you.